developed one of the first fully commercial battery projects in the UK. This was E.ON's successful bid into National Grid's enhanced frequency response tender with a 10 megawatt lithium-ion battery project, which we actually started construction 2 weeks ago at a site next to our Blackburn Meadows power station in Sheffield. This webinar is part of a series of webinars which E.ON UK is running to explain the benefits of the energy storage solutions which we are offering our customers. Our offerings are all shown on the slide in our solutions pyramid, so look out for future webinars in the coming months which will cover the topics of on-site generation and virtual power plants. The aim of today's webinar, however, is to provide you with an introduction to large-scale energy storage solutions which E.ON is now offering to our customers. In the following slides, we will explain what energy storage is, why in the past few years it has suddenly become a hot topic. We will also show you what E.ON has and is currently offering, and most importantly, how these solutions can benefit and bring value to your business and operations. Before we go on, I've already used the term large-scale energy storage, but what do we actually mean by this? By large-scale storage, we mean solutions that have a power output and input of more than several hundred kilowatts at the small end, up to tens of megawatts at the top end. This is a huge range of different powers, and the actual size of the system and the storage capacity deployed will be dependent on the specific site applications which it is deployed for. E.ON can offer solutions at all of these scales, and currently the majority of our solutions are provided by various battery technologies. We'll explain this more as we go through the presentation, but these systems are best suited for large energy users and not for small SME or residential customers where small off-the-shelf systems of tens or hundreds of kilowatts are better suited. But keep an eye out, as in the coming months E.ON will soon be launching our own exciting PV plus battery residential system into the UK market. Finally, before we go on and make a start, at the end of the presentation we'll have time for a few questions. So please, as we go through the presentation, if anything isn't clear or you have any questions, use the Ask a Question function to submit your questions, and we'll try our best to answer these. If we don't get round to answering all of these, we'll come back to you in the coming days. In the coming days, you'll also receive an email with a copy of these slides, and we will also answer any unanswered questions. So, why is there an increased interest in energy storage at the moment? To answer this, we need to look at the changes which are occurring in our electricity system here in the UK, but also across Europe and most of the developed world. As shown on the slide, we're currently shifting from a centralised energy system dominated by large fossil and carbon power plants to a decentralised system with smaller low-carbon generation assets, such as gas and biomass CHPs, and an ever-increasing amount of intermittent renewable energy, such as PV and wind. The changes in the system are being further catalysed by new smart technologies, which at the same time, for example, through technologies such as electric vehicles, are also increasing the total electric demand of the country. This is putting further strain on an electricity system which in some areas of the country is near to its full capacity or close to the end of its working life. In this decentralised world, more flexibility, i.e. the ability to detach supply and demand, is required at all levels of the system. This is needed to keep the system balanced, mitigate the problems of the decentralised world, and run the system in the most sustainable way. This is the main reason why there is a huge technical interest in storage at the moment, as storage provides you with the ultimate source of flexibility, with a dedicated asset that can provide you with both positive and negative flexibility without interrupting power supplies, which for businesses gives you complete control of your operations, allowing you to run when you want to. This explains why there is an increased technical need, but so far we haven't yet considered economics, which is the main driving force for the huge interest in energy storage projects at the moment. Commercially viable and economically attractive storage projects have in recent years emerged. This is due to a combination of several factors which are shown on the slide at the moment. Firstly, some of the main technical challenges of batteries have been improved. For example, batteries now exist with high enough energy densities, lifetimes and efficiency to allow them to be deployed on a commercial scale. Lithium-ion technologies currently dominate the industry, but in the coming years, other emerging chemistries could also become increasingly viable and suitable for specific application. Secondly, the economic challenges associated with the cost of storage technologies have also improved significantly. Since 2010, the cost of lithium-ion batteries decreased by around 75%, or approximately $1,000 per kilowatt hour, to around $250 per kilowatt hour today. Here we are quoting only the battery pack costs, which typically make up 40% of total costs of a stationary storage system. These cost improvements have been achieved due to the significant scale-up in production, with many so-called gigafactories coming online around the world. These have been built by battery and car manufacturers to address the world's increasing demand for batteries in sectors such as consumer electronics and electric vehicles. Costs are expected to continue to improve, with many industry players predicting that costs will decrease by more than 30% to below $200 per kilowatt hour by 2020. Finally, in many countries around the world, governments and industry are addressing some of the regulatory barriers which have prevented storage systems from attaining their full value in a system that was originally designed for large centralized plant. For example, in the United States, several states have now mandated volumes of energy storage which must be deployed onto the electricity system. Here in the UK, the government is exploring changes, but in the meantime, the transmission system operator, National Grid, has led the way by redesigning several of the central market services which it procures to allow new technologies such as energy storage to compete fairly in these markets. So far, we've considered the need for energy storage, but how can you physically store energy, and why are batteries such a popular choice for large energy users? This slide shows the numerous energy storage technologies that exist, and they're all grouped depending on the energy that you put in and get out of the system. The first thing worth noting is that energy storage is not a new thing, and various technologies such as pumped hydro have been widely used in our electricity system for almost 90 years. Each technology also has different positives and negatives. Focusing just on the power-to-power technologies in the top row, pumped hydro and compressed air energy storage are huge utility-scale technologies that require a lot of land or space in underground caverns. Flywheels and capacitors, on the other hand, are much smaller technologies, but they are only suitable for storing energy for short amounts of time. Apart from the relatively new technology of liquid air energy storage, that leaves batteries, which for large energy users currently offer the most attractive technology due to a number of benefits over other power-to-power and storage technologies. These benefits include that within the battery box there is a huge range of different technologies and sub-technologies, each of which have different properties and make them suitable for particular applications. Batteries are also modular and therefore scalable to particular applications which they are applied in. You can build batteries up from the individual cells into modules and then racks, thus scaling the power and energy capacity from a few watts and watt hours to any size system up to tens and even hundreds of megawatts and megawatt hours. Other benefits of batteries include that they are not physically constrained to one location and can be easily integrated into the existing electrical infrastructure of a site. Finally, out of all the power-to-power technologies, batteries have one of the highest efficiencies of between 80 and 90%, meaning that this minimizes energy losses to an absolute minimum when charging and discharging the system. Hopefully this has explained why energy storage is needed and why it has emerged as a viable solution for large businesses. I'll now hand over to Davide, who will explain what E.ON is doing and offering with energy storage solutions and how this can benefit your business.
Thank you, Mike. So I will make a start by giving you a quick overview of why we believe we can be your partner of choice for energy storage solutions. As you might have heard from the news, last year E.ON made the decision to spin off all conventional power generation assets into a separate business called Uniper to fully embrace the new energy world. This means that the new E.ON is now even more focused on developing smart, sustainable and affordable solutions for our customers. One of the key differentiators of E.ON when it comes to battery storage is that we do a lot more than just selling batteries. Energy storage is one of the many energy solutions in E.ON's portfolio, which also includes energy efficiency, on-site generation and virtual power plants. We are fully technology agnostic, and therefore our aim is not to sell you a specific product, but rather a tailor-made solution, which can help you achieving your energy, financial and sustainability targets. This also means that we can offer battery storage as either a standalone system or as part of an integrated energy solution, depending on specific needs. We leverage the E.ON's Group extensive knowledge of the energy industry and markets to ensure that we can extract the maximum value from the battery solutions that we develop for you, in terms of both savings from behind-the-meter applications and also revenues from central markets. And finally, we have extensive experience and expertise in battery storage. We started several years ago with R&D projects, to gain technical knowledge of different technologies, and then successfully brought this to the market with our commercial battery projects, including the Blackburn Meadows one in the UK. So what can a battery actually do at an industrial and commercial site? So if you look back, traditionally batteries have been seen as just uninterruptible power supply, which is basically a passive system sitting idle most of the time until something goes wrong, for example, a loss of power supply. Battery systems today are much smarter than that, and by using sophisticated control systems, they can target multiple applications. To give an example, the same battery system can provide backup power on site when power supplies goes off, improve the quality of your supply, for example, avoiding voltage fluctuations, also shave your peaks demand, thus reducing the grid charges in your energy bill. In the UK, for example, this would be triads, duos, and capacity market fees. But also the battery can generate revenues from central markets, for example, balancing services and reserve services. Other possible applications include energy arbitrage, leveraging the high volatility of cash-out prices on the imbalanced market, and optimization of your on-site generation, for example, providing ramp rate control for renewables and maximizing self-consumption. In a couple of slides, we'll show you how multiple applications can be actually stacked up to achieve a profitable business case. But now we would like to show you a bit more about the footprint and how a typical battery system looks like. So as Mike said earlier, our team develops battery solutions ranging from hundreds of kilowatts to tens of megawatts in size. The picture on the top left of the slide shows an example of small-scale solution which can be easily installed both indoor and outdoor in a cabinet. The picture shows a flow battery system that we installed at a SME customer site in Somerset in the UK. For megawatt scale outdoor systems, we would normally use modified shipping containers, either 20 foot or 40 foot, depending on available space, like the one shown in the top right picture, which E.ON installed in Germany. To give you an idea of footprint, a 40-foot container can host a complete system with 2-3 megawatt of power and about an hour of duration. All the system components, including battery racks, power conversion system, HVAC, fire and safety systems are installed inside the container. And the advantage of containerized systems is that it allows minimizing site work, which is typically limited to building foundations if required and plugging the battery modules in dedicated slots in the pre-installed racks, and also connecting the system to the local electrical infrastructure. So it is pretty much a plug-and-play system in this case. Only for very large outdoor systems rated at least tens of megawatts, building a purpose-built battery building might be a cheaper option. So thanks to the high degree of modularity of lithium-ion battery systems, we can also develop bespoke solutions and retrofit this inside existing buildings, leveraging our experience in managing and executing complex construction projects. Talking about the timeline for this kind of projects, it can be anything between 6 months for the smallest projects up to 12-15 months when we talk about multi-megawatt scale projects. And now, as promised, in this slide we show an example of how different solutions can be, different applications can be stacked up to generate a profitable business case. In this waterfall, we are showing a case that is referring to the UK, but similar concepts can be also applied to different countries and markets. Also, in this waterfall, we've omitted the actual figures, and the reason for this is that we want to give an overview, a flavor of how a battery can add value to your business, but the actual business case depends on site specifics and location of the system and project. Also, in some cases, one application would be enough to create an attractive business case. So now let's go through the different components of the waterfall on this slide. So the CapEx represent the cost of the complete battery system, including installation and commissioning costs, and it's mainly driven by the megawatt rating of the project and also the duration of the battery system. But it can also be affected by project-specific requirements, such as the level of resilience and the complexity of the installation. There might also be extra costs, for example, site-specific costs like upgrade of grid connection, and we will evaluate this on a case-by-case basis. All these costs are included in other CapEx in the waterfall. The O&M cost includes both the traditional O&M services and warranties, but also a continuous optimization of revenues and savings that we will carry out throughout the lifetime of the asset. The other OpEx includes the energy cost, which is basically driven by the energy losses in the battery, which are about 10% of the total energy charged in the battery. This business case is based on a combination of savings from on-site applications and additional revenues from central market applications. The on-site savings are generated by discharging the battery at peak hours to shape the site demand, thus minimizing triads, duos, and capacity market charges that normally make up about 40% of the electricity bill for industrial sites. Then during off-peak hours, the battery system can earn additional revenues by providing balancing services such as fast frequency response and reserve services such as the capacity market to the grid. Also, by aggregating batteries and other assets in our virtual power plant engine, we can unlock and optimize the central market revenue pools, leveraging synergies of different technologies and allowing small aggregated assets to achieve the rating threshold that applies for certain applications, such as the capacity market. By stacking up multiple applications, today we can already achieve 4 years of payback or less, and this is just a fraction of the 10 to 12 year guaranteed operational lifetime of the system. So in this slide, we want to show you 2 examples of large-scale projects that we are currently constructing. On the left-hand side of the slide, you can see the Blackburn Meadows project, which Mike described earlier. This system is expected to start operations before the end of this year. And we have already been awarded contracts by the TSO and National Grid, both for the provision of enhanced frequency response and for capacity market. Blackburn Meadows was one of the only 8 projects to be awarded an EFR contract in a very competitive auction with 5.6 gigawatt bids, mostly coming from batteries. On the right-hand side, we got the Iron Horse project, which are constructing in the US, in Arizona. This is a 10 megawatt, 2.5 megawatt hour lithium-ion battery system coupled with a PV system with 2.5 megawatt peak. Start of operations for this project is expected in March this year, and the battery system is used both to optimize the generation from renewables, but also to provide services to the grid, like frequency response and voltage control. I think it's worth noting that these are just 2 relevant examples, and we have many more battery projects based on different technologies, for example, lead-acid, lithium-ion, and flow batteries, used for different applications, going from grid balancing services to renewable integration, microgrids, and lots of grid solutions, and all over the world. For example, we're operating in UK, Germany, US, Africa, and Sweden. I will now hand over back to Mike to explain the next steps if you want to further be involved with storage.
Thanks, Davide. We're coming to the end of the webinar now, and hopefully this has left you wanting to explore the potential of energy storage solutions further. Just to summarise, E.ON is now offering commercial energy storage solutions to our large energy users. We have extensive experience in deploying and managing storage systems around the world. As we're technology agnostic, we have the ability to provide your business with the right solution, and through E.ON's virtual power plant, we can optimise and provide market access to allow you to maximise the value and additional revenues from central markets, thus ensuring that the energy storage solution is utilised throughout its full lifetime. On the screen at the moment, you see a summary of the benefits that energy storage can bring to large businesses. These include reducing your net energy spend by optimising and reducing power use at peak times, future-proofing your business's exposure to future price volatility and additional non-energy related fees, improve and guarantee your supplies, your power supplies and security, preventing issues on the grid affecting your business. As we said, through E.ON's virtual power plant, we can provide you access to central markets. And finally, storage increases and improves your company's sustainability and at the same time can contribute to the country's security of supply, thus further increasing your company's green and energy credentials. If you would like to find out more, in a moment and after the webinar via email, we will provide you with our contact details. The next step would be to get in contact with us to arrange a discussion and explore potential options further. Typically, we would collect some initial information to allow us to provide you with an initial proposal and value assessment, which we will then refine further with you. After this, and only if storage solutions are right for your business and needs, we would finalise the development of the solution whilst agreeing commercial and technical terms prior to the storage solution being delivered, installed and commissioned to allow you to start realising the benefits. I'd like to take this opportunity to thank you for your interest and for joining this webinar today. We will now answer a couple of questions which we have received from you. Whilst we quickly look at these questions, as you'll see on the screen at the moment is our contact details. So one of the first questions we have is, what is the business model which we are offering? Do you want to take this one, Davide?
Okay, so basically, as we've seen in the waterfall chart, at the moment we are considering a design, build, and operate business model. So we would offer you a contract for constructing the battery asset and also another contract for O&M, but also optimization of revenue streams. But also we are open to consider other commercial models, for example, leasing agreements.
Okay, the next question we have is, do I need to be an E.ON supply customer to buy an E.ON or to buy an energy storage solution from you? In short, the answer to that is no. However, there would be some benefits that could be leveraged if E.ON was your supply customer. These are the sort of topics that we would discuss further with you when developing the solution. So in short, no, it doesn't affect us offering you a solution, but we could discuss it further. I've been told that we're out of time now, so I think the rest of the questions we'll have to pick up separately offline. Once again, we'd just like to thank you for dialing in to this webinar, and we look forward to hopefully exploring potential storage solutions with some of you. Thanks very much.